So this is lesson 4-2, negative exponents. Okay, so put that at the top of your notes in your composition book. So this first part says a negative exponent is the result of repeated division. So that kind of sounds confusing, but I really like this table that they show us, and they use the main number base 10. So they start out, okay, well, 10 to the third power, we know that that means 10 times 10 times 10, which equals 1,000. Tens are so nice to use for exponents because whatever the exponent is, that's how many zeros will be in your answer. So 10 to the second power is 10 times 10, so 100, 2 zeros. 10 to the first power, we don't ever write that because that just means 10. There's 1 10 or 1 0. Now, 10 to the 0 power means there's 0 zeros. Okay, so any number to the 0 power will always equal 1 because it means there are no 10s. So it's just 1. And if you notice, this works because they're saying you're dividing by 10 each time. Now, if we look further, 10 to the negative 1. So what we would do is we would turn that into a fraction. It would be 1 over 10 to the first power. By putting it under 1 and making it a fraction, we can now make our exponent positive because it's a negative number, so it means it's really small. Okay, so it's 1 over 10, which makes it a fraction, which makes it very small. 10 to the first power, we know up here is just 10, so that would equal 1 over 10. I didn't mean to cross that out. I was trying to circle it. Anyways, next one. 10 to the negative second power would be 1 over 10 to the second power. And 10 to the second power means 10 times 10, so that would equal 1 over 100. And then they show 10 to the negative third, and this could go so on and so on. 10 to the negative third would be 1 over 10 to the third power, which equals 1 over 1,000. Because negative exponents means it's getting smaller. Excuse me. So, looking at examples, we're going to go ahead and look at example 1 and 2 before I pause the video to go over it. But looking at example 1, write each expression using a positive exponent. So kind of what we just talked about. You can't do 2 to the negative third power because this exponent is supposed to tell you how many times it's being multiplied. So we first have to make it positive before we could solve it. So that would make it 1 over 2 to the positive third power. And they didn't ask us to solve, so we would just leave it that 1 over 2 to the third power because then we could solve it. B, we have m to the negative fourth power. So that would become 1 over m to the fourth power. Okay, I do want you to do problems A, B, and C on your own, so you can pause the video and do those. I'm just not going to go over them until after we look at example 2. So pause the video now and try 1A, 1B, and 1C. Okay, looking at example 2, write each fraction as an expression using a negative exponent other than negative 1. So on the first one, this will make a little more sense when we get to B. On the first one, we have 1 over 4 to the second power. So now they just want us to write it using a negative exponent. So we know since it's 1 over that, if we drop the fraction, that's just 4 to the negative second power. Now looking at B, this is what they mean by other than negative 1. We could just say, oh, well, that's 100 to the negative first power. They don't want us to use that. So that means we have to figure out what number we could write to an exponent. So they said here, okay, well, we know 100 is what 10 times 10 equals. So we could say 10 to the second power, 1 over 10 to the second power, which then would mean it's 10 to the negative second power. So this one you kind of had to think, okay, well, what times itself could equal 100? Or it could be to the third power. Who knows? So now you're going to pause the video and work out 2A, 2B, 2C, and then I will work out 1A, 1B, 1C, and 2A, 2B, and 2C. Now we're going to look at all these problems. On 1A, we have 3 to the negative fifth power. We're writing it with a positive exponent. So since it's negative, that means it's going to go under 1 on a fraction, 3 to the fifth power. We're not solving anything, we just leave it. 1 over 3 to the fifth power.
1b is y to the negative third, so that would become 1 over y to the third power. And then c, remember anything to the 0 power means that number is there 0 times. So it just comes out to 1. Okay, then on 2a, b, and c, now we're writing it with a negative exponent. So 1 over 6 to the third power, you just undo that, 6 to the negative third power. Okay, b and c, there was an added step because there's not an exponent yet. So 1 over 25, we first have to figure out how we could write 25 using an exponent. And it's 5 to the second power because 5 times 5 is 25. Then we write it with a negative exponent, 5 to the negative second power. Then c, 27, we can write that as 3 to the third power because 3 times 3 is 9, 9 times 3 is 27, and that is 3 to the negative third power. That one made you think a little more.
Looking at example 4, it says evaluate. There's our favorite word, which means what? Solve. Yeah. Okay. So evaluate 4a to the negative fifth power if a equals negative 2. So on here, hold on, I'm looking at how they did this. Okay, so the first thing we do is rewrite it. So 4 times a to the negative fifth power. So for me, you can definitely go ahead and plug your number in. To me, it makes a little more sense to go ahead and show using positive exponents. So 1 over a to the positive fifth. And then plugging my number in, but it doesn't necessarily matter. So they plugged in negative 2 for a. It goes in parentheses, so that way the negative is included. So 4 times 1 over negative 2 to the fifth. Now, they left it like this, and that is perfectly fine. Since it's 4 times 1 on top, you could just put 4 over negative 2 to the fifth power and solve it that way. Either one is correct. So, using what they did, so they said, okay, well, it's 1 over negative 2 to the positive fifth power. Focus on that first. Plug in negative 2 to the fifth power in your calculator, and you get negative 32, because it's negative 2 times negative 2, which is positive 4, then times negative 2 again, which is negative 8, times negative 2 again, which is positive 16, times negative 2 again gives you negative 32. So then they said, okay, well, if you put 4 over 1 and make it a fraction, we're multiplying fractions. So they cross-canceled and said, okay, so 4 divided by 4 is 1, negative 32 divided by 4 is negative 8, and then said 1 times 1 is 1, over 1 times negative 8 is negative 8. Excuse me, sorry. So then over here, 4 over negative 2 to the fifth power would mean that's 4 over, and they already worked out negative 2 to the fifth power for us, which is negative 32. From here, we would just simplify, which means we would divide both of these by 4 and get 1 over negative 8. Okay, these are not simple. They take a little bit of thinking, so it's okay to have multiple steps like this written down, because trying to do it all in one is not going to work, and it's very confusing. So on this one, you're going to do 4b and 4d. Oh, no, I don't think I did that. I think I did 4c. So 4b and 4c. Yeah, let's do c instead of d. We won't do d or a. So 4b and 4c. Pause the video and work those out, and then I'll work them out on the board for you. This is the last example we'll look at today.
On example 4, it said evaluate these problems, and they tell us that m equals 4 and n equals 3. So we have 6m n to the negative fourth power. So 6 times n, m times n to the negative fourth power. So only the n is being raised to that negative fourth power. Okay, well, we can't solve it when it's a negative exponent. We have to make it a positive exponent first. So that would mean we have 6m times, if I rewrite that, that'd be 1 over n to the fourth power. Okay, well, 6m times 1 over that, you can just put 6m on top over n to the fourth power. So we could have gone ahead and plugged in. I normally like you to plug in first, but I just wanted to show you it's a little easier to rewrite it first before we plug numbers in. So I have 6 times m, which is 4, n is 3. Still got to the 4th power. So now I can solve. 6 times 4 is 24. 3 to the 4th power. Well, 3 times 3, I write them down and I cross them off. 3 times 3 is 9. 9 times 3 more is 27 times 3. Double check that in your calculator, or you could just go ahead and do 3 to the 4th power. We get 81. 24 over 81. And we can divide both of those by 3. 24 divided by 3 is 8. 81 divided by 3 is 27. 8 over 27. Okay, I know these are not simple and easy. They take a lot of thinking on rearranging to get a positive exponent because we can't solve a negative exponent. So on 4C, don't forget this negative out here. It means negative then n. So n, sorry about that. Okay, that was in the video, not in real class. Okay, so now negative n to the negative 3rd power. So let's go ahead and rewrite this. If we do 1 over, it is still negative n to the 3rd power. All we did was get rid of the negative exponent when we did that. Okay, now we're going to plug in 3. This negative would be outside of that, so that'd be 1 over negative 3 to the 3rd power. Okay, 3 to the 3rd power, 3 times 3 is 9, 9 times 3 more is 27. We still have that negative. So it's the whole fraction is negative. I wrote it on the bottom, but you can write it here also or on top. It doesn't matter. But it is negative 1 over 27.